The one thing I would say to always be careful of is don't learn and then not use, because very quickly that knowledge.
Yeah.
And you realize where your gaps are. So when you learn, everything looks so easy. So they're doing it and you're like, wow, I can do that. When you sit down and actually do it, it's a completely different world.
Yeah.
So then the next thing would be, so one, pick a project, dive in, then find the resources, learn, and then apply. And then when you apply, don't be discouraged, because it will be very difficult and there will be a lot of changes.
Yeah.
Something completely new and very disconnected to the actuarial world on the technical programming side.
Yeah.
So dive in, and when it gets difficult and when you struggle, take a break and then jump back in. So if, for example, I wanted to build a website. So I run a website and I wanted to build an app on the website that can do change added reserving calculations.
Okay.
And to get to the point where I can actually have that functioning, took me about 2 years, a lot of pain and effort in my own time. And this is all having some experience of programming in high school as well. So I started out at the beginning of the 2 years, and I tried it and I bashed my head against the wall, and I took a break, and then I looked at more resources. And 2 years later, trial on the weekends and early mornings, eventually I cracked it. And then you look back and you say, well, actually, it was pretty simple.
Yeah.
If you think about it, but
all those micro learnings, right?
Little bits of that. If you don't get discouraged, and you just enjoy the process, don't try and rush to get to the at the end. If you enjoy the process, you'll appreciate the process, and before you know it, one day you'll have the end result, and you'll be so much better for it.
Yeah.
And then you just pick the next project.
And you also don't mind class. That stage, right? You only really, really gain proficiency in sort of getting into the nitty-gritties and getting frustrated. I don't know if you can ever learn without that self-appreciation. And I guess also something that I would maybe add to that is that you can use the AI to help you learn about AI, right? So, I mean, you can use ChatGPT to help you find resources and help explain things and summarize things and direct you to places that then can help expose you to an area that you maybe feel that you're a little bit underskilled in.
Yeah, there's no better time to be alive to learn something than now.
Yeah.
Because you have this expert you can ask your questions to. You can tailor it directly to you. So a lot of the problem in my learnings was I had a specific problem I needed to solve. And you go on Google and you find problems adjacent. But you have to do the work of trying to convert that to the solution. Where if you ask ChatGPT, it will do that for you. And you'll get the solution tailored to your problem. And then you can dig in and say, well, I didn't understand this part. Can you
unpack this for me? Yeah.
You can pay someone, we can get an instructor to do that for you. But having a model like ChatGPT available completely transforms the way you learn. So
access, right?
Just access, But I would say don't rely too much. So challenge yourself still, because you can fall into the trap of always asking Chat.
Yeah, so it becomes convenient, right? And so my next question to you would be, you strike me as someone who's continually learning. So you've done this paper and you kind of got to grips with large language models and how that applied in various actuarial contexts. What's next? What is it that you are exploring in this space that is of interest to you?
So closely linked to the large language model is the next evolution of large language models, and that is what's called a multimodal model.
Okay.
So they're all there. There's very complicated. Please try to say that 3 times. So if we think of a large language model, we focus on language. As I said at the beginning, it learns from text how to generate more information. But humans don't only learn from text.
True.
A child learns from touching. They learn from vision. They learn from hearing. So can we build a model that learns from vision, from hearing?
That'd be amazing.
Can you feed it YouTube videos, for example? Can you feed it audio and then teach it to learn and extract information from that? So a large language model can generate text about the world, but it can't describe the world based on its knowledge of what the world looks like. So I've seen the world, it's only heard descriptions. So the multimodal model is, can we feed in video? Can we feed in audio? Can we feed in anything else that just massively expands the ability for this model to learn and understand the world?
Sure.
And that also opens up the fact that as an actuary now, you don't have to feed in text only. You can feed in an image. So you can feed in a picture of a damaged vehicle and get a claim estimate.
Sure.
So the next step is leveraging multimodal models So the famous one now is Gemini from Google. So that's a multimodal model.
Okay.
ChatGPT, you can give it images, but it's actually not all one model. It's
got fragmented.
It's different pieces, so it's sending the image to another model, actually. But Gemini is learning from all these different things.
Sure.
So the next step is, how do we leverage multimodal models, and what does that mean? So we can speak to a large language model and get help, but can we pop in pictures of claims or pictures of the world, they understand risk for insurance from that?
Sure.
Yeah.
Sure. And on your LinkedIn bio, you have the term modern actuary. Now, I have to ask you, how would you explain what a modern actuary is? Because I think many people should aspire to be in maths. But how would you define that?
Yeah, so when I came up with the term, so I realized actually a while after the fact, I didn't actually come up with the term myself. I found an old piece of paper that said modern actuary, and obviously my mind leashed up. Wow, that's very cool. That's probably to call my website. But if I were to term what a modern actuary is now, I would say, the actuary part is still important. They're still an actuary.
Yes.
But the modern part is that they use newer technologies like programming, data science, and machine learning to solve problems in more modern ways. So the world has changed drastically from the very static Excel or calculator-based world to a world where data is widely available and can be utilized in very powerful ways. So the modern actuary brings in the wealth of extra data using programming, using machine learning methods to augment and improve their work to a more advanced state. So I wouldn't say they're drastically different from a normal actuary.
Yes.
I think it's just the tools that they use to solve the problems are more programmatic, more machine learning, more powerful for the world of data that we live in now.
Okay. And you alluded to neuroscience, this website.
Yes.
And so many of our listeners, having listened to this conversation, would like to know more about that. Can you kind of speak to that?
Yeah, so the website is modernactuary.co.za. And I started it during COVID just because I wanted to share my learnings on applying data science and programming to actual work. So what I do on the website, every few months, whenever I get a bit of spare time, I write an article about an interesting problem. So the first one I wrote was on chain ladder reserving. So we all did it in Excel workbooks, and I always found that very painful because you have to click around and change.
And it's very easy to click on the wrong cell and your development factor's wrong.
Yeah, it's just a very painful process. So I at one point said, I Googled are there programmatic ways of doing chain ladder reserving. I found the chain ladder Python package and I started using it. And I thought, well, this would be great if everyone knew how to use it.
Was that freely available?
Freely available, yeah, open source. So I just wrote an article that said, this is how you use it. And then I posted it and I shared it on LinkedIn and I said, if you're interested in using it, read this and hopefully it helps you. And then it just snowballs. And then I wrote articles on a whole bunch of other things. For example, another one on reserving, I threw the triangle into ChatGPT and I said ChatGPT predicts what the claims are going to be.
Yeah.
And you get some interesting results. It's not how you should use large language models, but it's a way to use large language models.
Well, it's also an interesting way of seeing how they're giving you output.
Yeah.
Right. Given a slightly different prompt, even if it wasn't the prompt that they were necessarily designed for.
Yeah, exactly. So they're designed for language, but if you give it numbers and trick it into thinking it's language, maybe you can get an answer out. And I also wanted to develop apps to showcase the power of programming. So there's currently 2 apps on the website. One, the chain ladder app, where you can just click around and get chain ladder or IBNR reserves. And another app for reinsurance, where you can just generate losses, apply a whole complicated reinsurance structure, add layers, change it around, and get an output. Intent of the website, when I wanted to do, is to demonstrate that these things are possible, and hopefully spark in people the idea to do it for themselves as well. We say, well, that looks great. Let me try and do it and learn and apply to your own work.
Okay. And talking about your own work, how are you bringing these various spaces of interest and sort of newfound proficiency into the work that you're doing in the catastrophe and climate change space?
Yeah. Yeah, well, for one, I never touch Excel. So always trying to avoid Excel as much as possible. But so the climate space is an area where programming and data science shines.
Yeah.
Because the amount of data is so large, you can't do it any other way.
Okay.
So I often think now that I'm less of an actuary than I've ever been before. Mm-hmm. Although I've got the actuarial underpinning and the development skill set, I work a lot more as the programmer and a software developer and as I guess you could say, data scientist or analyst. So the way I bring it into my work is say, for example, the problem of understanding how weather systems impact the occurrence of risk. Yeah. So, for example, maybe a storm. Then I would go and say, well, what data do we have on weather? Yeah. And if you go online, you can find lots of different data sets on weather over history, and I can pull all that in. But because the data sets are so large, I have to use Python to pull it in. So I use Python to pull it in, and I store it on my computer. And then the question is, well, can I find a relationship between these storms and claims, insurance claims? Yeah. And then the actuarial side comes in, because then I take my claims data and I transform it in an actuarial way into a data set that answers the question of this is what our claims look like, and this is what our loss ratios look like. And then I combine the two, and that's where data science comes in. Gotcha. So now I've got the data and I've got the weather data. How do I combine it and build a model that learns? I can't use traditional actuarial models because they're more tailored for traditional actuarial problems.
Exactly.
So I have to use things like machine learning models like random forests, or deep learning or neural networks or whatever. Generate the model. Then the programmer comes in and says, well, we've got the data, we've got the claims, we've got the model. How do we put this into production? Mm-hmm. How do we leverage it within the business? And that's our software development and engineering. Mm-hmm. So I have to put up computer systems that run the code. I have to develop interfaces that I can send the data to the interface and get a result out. And then I embed that in the business. Then the final question is, well, how do we as an insurance company use this information? So then it says, okay, we've got the result. What does it mean? How do we bring it in? Do we bring it into our pricing models? Do we bring it into our catastrophe models? Yes. How do we use it? Do we use it as a risk mitigation tool?
Gotcha.
And then the actuarial side comes back in.
Yeah.
But really 90% of the job is sitting down, programming and building models. Yeah. Which I enjoy very much.
It's just, and I think that's, a learning maybe for any actuarial student is that there are many different spaces an actuary can work in, and I think what you can attest to and your career attests to is that you do actually have that agency, and you kind of just have to dig your heels in and kind of learn the skills that you want to in order to do the work that you want to do. Yeah. So I think, that's very inspiring actually. But last question I would like to ask, and it's kind of how I always end off the podcast, is what piece of advice or encouragement would you give to an aspiring actuary and possibly thinking of yourself when you were in that space? What do you think would be pertinent to say?
Sure, I think it's a deep question. I would say most importantly is don't, in this new world of data science and new technologies, don't discount the actuarial profession. Mm. Don't give up on your studies, or don't, think it's not worthwhile anymore. I think the most important thing I could have done, and anyone can do this, going for the actuarial career path, is to stick to the traditional, the foundation, the basics, and get that qualification at whatever level you desire. Mm-hmm. But stick to the exams, get to a point where you had your foundation in your experience in the insurance world, do your time in the work so that you have a strong foundation that you can then build up on and take the risks with, or take risks in your career with. And then I would say, so always have the foundation and never give up on learning. So I think the most important thing is don't become comfortable with what you know and stop challenging yourself. Yeah. So that can be anxiety inducing to some, because it's like...
It can, because they just aspire for faster. And then once they get faster, they're like, okay, I'm done learning. That's just the beginning, really.
It's just the beginning. And so I'm not saying you got to grind and push and hustle the whole time to try and push yourself forward. But every time you look at a new problem, just think about it and don't just go through the motions. Look at the problem and say, well, how could this be done better? And if you don't learn, dig a little deeper and see if you can learn and pick it up. And eventually you'll get to a point where you answer for yourself how it can be done better. You do it yourself, or you get someone else to do it. But that constant learning, I think, will always be beneficial for you in any career, because one day you might move out of insurance or a strictly traditional actuarial area